Hello everyone, and today we are going to look at geometric optics. First of all, we're going to start with some geometry theorem, and then next we continue with law of refraction, and then by then we do some question. However, if you want to skip, you can skip until law of refraction, and you can look at the question instead. So let us begin. The most fascinating things about light is it follows abstract well-defined path, most particularly in the geometric pattern. However, this geometric pattern is only an approximation of how light propagates through space and boundary. These are the geometric theorem that we are going to take a look briefly. Linear pair, alternate interior angle theorem, and exterior angle theorem, including the alternate exterior angle theorem also. Linear pair. So whenever we have a line crossing uh, a single line, we call the two created angles as linear pair angle. These two angles are supplementary to one another, meaning that they add up to 180 degree. So if we don't know one of the angle, but we know another one, we can subtract 180 degree with 120 in order to find the unknown angle. Alright, another additional information is all linear pair are supplementary angle, but not all supplementary angle are linear pair. Suppose that we have this one angle separated not on the same uh, line that we can see on this above. They are not uh, they are not called as linear pair because they are not adjacent to one another. So this is some sort of good things to know. Continue on with alternating interior angle theorem and alternate exterior angle theorem. So we call the angle within the parallel line as the interior angle, and the angle exterior is the angle that is outside of the parallel line. So when we have a line intersecting two parallel lines, they will create six angles. So these six angles are interconnected with each another, meaning that they have their own relationship, and their relationship is alternating interior or exterior angle theorem. Here we can see the interior angle. 3 and 6 are congruent, therefore 3 and 6 has the same angle, including 5 and 4. This inside the parallel line, we call this as alternate interior angle theorem. Meanwhile, on the outside, 1 and 8 are congruent, 7 and 2 are congruent. These two pair are alternate exterior angle theorem. Alright, continue on to the exterior angle theorem. The exterior angle of a triangle is the sum of two remote interior angles. So angle C is the sum of A plus B. Okay. Next is law of refraction. I'm going to fast forward. This law of refraction tells us the bending of light when light encounter different medium. When they go into a denser medium, the refracted ray will go towards the normal line. And if they are going from high dense to less dense medium, they're going to bend away from the straight line, away from the normal line. I mean. Oh yes. Before we proceed, let's take a step back. I want to add some info. Angle 1 and angle 4 are congruent because these two angles we call them as vertical angles, including angle 3 and angle 2, angle 5 and angle 8, angle 7 and angle 6. These are congruent angle because we call them as vertical angle. Continue on to the question. Question 1. Finding angle from horizontal. Light ray enters parallel to the base of an equilateral prism with index of refraction 1.5. Find angle of emergence from the horizontal. The question asks us to find the angle of emergence. So we have theta 4 as our angle of emergence, where question wants us to calculate it from the horizontal, meaning that they wanted us to find from the base, from from the line that is parallel to the base. In order for us to tackle this question, let's separate it into 4 angles. Theta 1 is the angle of incident. Theta 2 is the angle of refraction, including theta 3, the incident for the angle theta 4. And then theta 4 is the emergent angle. So they give us that the light ray is parallel to the base of the equilateral. Therefore, as we can see here, this is 60 degree, and when we look closely, these are somewhat alternating interior angle. Therefore, this angle must be 60 degree. Since the normal line is always 90 degree with the surface, therefore 90 degree minus 60 degree, we can get 30 degree. And in order for us to find theta 2, we use Snell law, and we get 19.47 degree. To continue on finding theta 3, we have 2 ways of how to calculate theta 3. The first way is we need to find, when we extend this normal line, both two normal lines, we can get a triangle, and then we need to find the angle of this triangle here. By then we can calculate, we know that one triangle has 180 degrees, so 180 degree minus this angle and then minus with theta 2, we can get angle theta 3. Another way is we can use another triangle up here, so we need to find this angle. By then, since we are given 60 degree here, and then we can minus it with 180 degree, 180 degree minus 60 and minus this angle. By then we can know this angle. Since this is 90 degree to the surface, therefore 90 degree minus this angle, we can get theta 3. Okay. Here I redraw back the triangle, and as we extend the angle, the normal line, two of the normal line, we will see the two normal line will converge to a one point. So I would like to call this point is point B and the angle is angle B. Now there's 2 ways of how we can find angle theta B here, and the first way is we can use this formula. Let's begin with the formula first. This formula, now we know that the angle apex is the sum of A and B is equal to 180 degree. Why? So let's take a look why. Here we have a polygon with 4 sides. The sum of this polygon is 360 degree. Now the angle that is normal to the surface is 90 degree. We have 2 of the normal angle, which is angle A and angle C, or rather known as DAB and DCB. Now these 2 angles are 90 degrees, so when we add together we will get 180 degree. So when we minus 360 degree with angle A and angle C, which is 180 degree, what we left is we will left with this angle B and angle D, which correspond to 180 degree, right? Angle ADC plus angle ABC will correspond to the remaining angle of 360 degree minus 180 degree of the sum of the normal line that we have subtracted before this. Therefore, we can, as we all know, that the apex angle is 60 degree. When we minus 180 degree with 60 degree, we will get the angle B, which is 120 degree. So this is the first way. The second way of finding, okay, let's continue on of finding theta B. So we already know the angle B here, which is 120 degree. So We also know the angle theta 2, which is 17.47 degree. So by subtracting, so we know that inside the triangle we have 180 degree total. So 180 degree minus with theta 2 minus with the angle B will give us angle theta 3. So here is the calculation that will give us 40.53 degree. Another way of finding theta 3 is by finding by looking at this triangle. Instead of looking at the inside triangle, we are looking at the up triangle here. So we need to find, let's say I make this as theta A and then next angle is theta B. The sum of all angle inside this triangle is 180 degree. In order for us to find theta A, we know that from the surface to the normal line is 90 degree. So we already know the angle of theta 2. Therefore 90 degree minus with theta 2 will give us theta A, which is 70.53 degree. Right. As I said previously, inside a triangle 180 degree is sum to 180 degree. Therefore 180 degree minus with 60 degree and minus with theta A will give us theta B. So this will give us 49.47 degree for theta B. So to find angle theta 3, we know that from the surface, the normal line to the surface is 90 degree. So 90 degree minus with theta B will give us angle theta 3. So that gets us 40.53 degree for theta 3. Similar as we use another method, also the same result, 40.53. So for me, I will preferably use this formula to find instead of using the triangle up here. I will use to find the angle B here to find theta 3. So that's that. I hope that's useful. Now we know the angle theta 3 is 40.53 degree. Now we need to find theta 4 before we can calculate it from the horizontal with the prism. So we're going to use the Snell law or law of refraction to find theta 4, because the light is encountering a boundary. That's why we need to use this Snell law. So that gives us theta 4 is 77.10 degree. Next is we're going to find the angle from the horizontal, since we already know theta 4. As we can see closely here, I made a yellow dash line which is parallel to the base of the prism. Here is the green line, where we need to find this green line because this is the angle of our interest, angle from the horizontal. So in order to find this green line, we need to subtract it with the angle purple here. Now we know that angle 60 here correspond to the angle 60 here also. This angle 60 degrees is the same as is part of the angle from the horizontal. This is alternate interior angle theorem, which they are congruent. Therefore, we also know at the same time the normal to the surface is 90 degree. So 90 degree minus with 60 degree will give us this purple angle here, which is 30 degree. So here's 30 degree. And then we need to subtract theta 4 with the 30 degree in order for us to find the green angle here. So 77.10 degree minus with 30 degree will give us 47.10 degree. So this answers the question. Now let's continue to the next question, finding the angle of deviation. Now there's two ways of how we can find the angle of deviation. The first way is by using the exterior angle theorem, and the second way is a little bit more easier by using the formula. And before we start, angle of deviation highly depend on the index of refraction. As we all know that as the index of refraction become higher, the speed at which the light travel in it become much more slower. Therefore, the angle of deviation will become much more greater. So we are going to continue with using the exterior angle theorem. We know that the exterior angle delta here correspond to the sum of theta A. Let's say I'm going to name as angle here as theta A, and the next angle is theta B. So the sum of two remaining angles is the exterior angle of a triangle. So delta is equal to theta A plus theta B. The question is, how we are going to find theta A and theta B? Well, as you extend the angle of incidence, pretending that it is not refracted towards theta B, we extend the angle of theta 1 towards the opposite side. We can know that theta 1 is the sum of theta A plus theta 2 because this is an apex angle. Theta 1 is congruent to both the sum of these two angles. Alright. Therefore, we can say that theta 1 minus with theta 2 will give us theta A. Alright. So 30 minus 19.47 is 10.53 degree. Next is we need to find theta B. Same as the previous, we extend angle theta 4 away, or not away, but to the opposite side of the normal line. So we know that the sum of theta B plus theta 3 is equal to theta 4 because these two are apex angle of theta 4, right? They are congruent. Therefore, theta 4 minus with theta 3 is equal to theta B. So theta 4 is 77.10 degree minus with theta 3, which is 40.53 degree. That will give us theta B, which is 36.50 degree. So we already know theta A and theta B, so plugging in into this expression to this exterior angle theorem, so that will give us 47.1 degree the deviation. So let's continue the next way of how we're going to do, by using the formula, right? So here we are going to look how we can use the formula to find the angle of deviation. So here is the formula. So don't get intimidated by this part of the formula. These are all Snell law of finding the angle theta 4, the angle of emergence. So if you can see, the formula starts with sine incident, which is sine incident is theta 1, and then the next they go for theta 2, finding theta 3, and then next to we can already get theta 4. All of these trigonometric function here is actually theta 4. Okay. Next is since n1 is air, so n1 is 1, so we can somehow not to be bothered by n1 anymore. So the simpler version of this formula is here. And we already know our angle of incidence is 30 degree, our theta 1 is 30 degree, our apex angle is 60 degree, and our index of refraction is 1.5. Therefore, we can plug in the value into the respective coefficient inside the formula, so that will give us 47.1 degree, similar to the previous answer using the exterior angle theorem. I must say that using the angle of deviation formula is much more accurate because if you are comparing to the previous answer, we already rounded off to the nearest decimal value. So right here we even get about several decimal places. And okay, that's that for this question. Now we're going to move on to the last part. My slide is stuck. Alright, solving. This is another question of finding the angle of minimum. As you okay, this is the similar formula from the previous part. However, I don't recommend using this formula because this formula only usable when the angle of incident is equal to the angle of emergent, and the refracted ray must be parallel to the base of the prism. So there's a condition for us to apply to use this formula, because this is for us to find the angle of minimum deviation, not the angle of deviation. So we can only get angle of minimum deviation when the angle of incident is equal to the angle of emergent only. So this is the condition, as I said. I is equal to E, incident is equal to emergent, parallel, and then the refracted ray is parallel to the base. Okay. So even though you use this formula to find the angle of minimum deviation, you use this angle to find the angle of minimum deviation, you still get the answer. However, if you use this formula to find the angle of deviation, you will get not slightly, will get the different answer. So I prefer you to still use this formula to find the angle of minimum deviation. Okay, I already given the answer. This is only for the sake of practice. So angle of incident, since the angle of refraction is parallel to the surface, to the base, so we must expect that 60 degrees somehow minus with 90 degree, we will get about 30 degrees. So the angle here must be 30 degree. So using the Snell law, we can get the angle of incident from the angle of refraction, right? And angle of incident at the second phase, since this somewhat angle is equilateral, so we can say that this angle also 30 degree. So you can also use the uh, apex angle formula, that 60 degree is 180 degree is equal to the sum of 60 degree plus this angle P. So let's try to calculate. 180 degree minus 60, so this leaves us with 120 degree. So 180 degree, a triangle consists of 180 degree. 180 degree minus with 120 degree will give us these two triangle. So we will get 60 degrees. So 60 divided by 2 will give us 30 here and 30 here. So that's that. And finding the deviation of the light ray, we can use this formula and this formula, but I prefer you to use this formula. And you also can use the uh, exterior angle theorem to find the minimum deviation of the light ray. You can still get the same answer of 37.11 degrees. So let's conclude for this video, and I hope you found this video useful for your test, examination, or any assessment regarding to your work or your study. And thank you for listening, and have a nice day.